we can recall what we learned in the last class. So last class we learned about the stresses. Okay, you know what is stress, okay, and the different types of stress, and we also learned the strain, okay, and the different types of strain. So this class we are going to learn about the analysis of bars of uniform and stepped cross section as well as analysis of bars of composite section. So before going to this topic, before going to solve this problem, you should know what is the principle of superposition. Okay, so this principle states that suppose imagine a system or a project, a product or object, they are subjected to different loads. Okay, they are subjected to a number of loads. Your task will be asked to determine the resultant strain. What will be the final strain because of these loads? So according to the principle of superposition, the resultant strain will be the algebraic sum of strain which is caused by the individual loads. So this is the principle of superposition, and we are going to apply this principle to solve the problems of uniform and stepped cross section. So this is our task today. So before solving the problem, you should know the criteria how to do this problem. You should know the steps to solve this problem. The first step will be the checking for equilibrium. So once a question is given, the question will be an object subjected to a loads, different loads, a uniform bar section or uniform cross section subject to different loads. You have to check for the equilibrium, whether the object, whether the system it is in equilibrium or not. This is your first task. The second task, so you have to divide the system into individual sections, individual parts. That is, you have to draw the FBD, that is free body diagram. This is what we learned in the previous topics. What is free body diagram? So free body diagram is a diagram which shows only the forces acting on the particular part or particular system. And finally, you have to calculate the deformation for each part or section, and you have to sum it. You have to add it. You will get the answer for resultant strain. So this is the principle of superposition. Now we can see a problem where we can apply this principle to determine the resultant strain. So this is the problem. The problem is given, that is a brass bar which is having a cross-sectional area. It is a uniform bar. So this question comes under uniform bar section. It is a cross-sectional area of 1000 mm square. Okay, it is subjected to an axial force. So there are different forces acting on the system. Okay, there are different forces acting on the system. The question is, you have to find out the total elongation of the bar. The total elongation means that it is otherwise called as total deformation or the resultant strain. Okay, please understand. Total elongation, total deformation or the strain, all are same. Okay, so and then Young's modulus of the bar is given as Young's modulus of the material. Okay, the bar is made up of brass. Young's modulus will be different for each and every material. So it is given as 1.05 into 10 power 5 Newton per mm square. So this is your given problem, and you can know that you know the parameters. What are the parameters given? The uniform cross-sectional area, capital A, it is 1000 mm square, and the Young's modulus is given. The Young's modulus for the brass material is given as 1.05. Your task is to, you are going to find out what is the resultant strain. This is your task. That is, you are going to find out what is DL, the total elongation of the bar. So now you have to remember the principle of superposition. So what is the first step? What is the first step? You have to check for the equilibrium. So I have again drawn the picture. Now you have to check for the equilibrium. So find out how to check for the equilibrium. So there are forces given 50, 80, 20 and 10 kilonewton. So now you have to add all the positive forces which you have to equate to the negative forces. So what are the positive forces? Positive forces, we have 80 kilonewton and 10 kilonewton. So this is plus 80